You can imagine that they might get deflected around a little bit when they go through the slits, but basically on the screen you would expect most of the electrons to appear opposite one or the other of the slits, with maybe a bit of a spread because they rattle around a bit when they go through. So you get lots here, and pretty much none in the middle. But that's not what you see. You see sort of stripes, a stripe on the screen where you get lots of electrons, and then a stripe where you get very few or none, and then another stripe where you get lots, and then a stripe where you get very few or none, and then another stripe, and then very few or none. So you get this stripy pattern. That pattern is exactly the same pattern that you would get if you sent waves through the slit. The fact that you get it from particles is interesting. But here's another interesting thing. You still get that pattern if you send one particle at a time through the slits. So it is, and let me use my language carefully, I was going to say it is as if the electron can somehow explore both paths, just like a wave can, and then interfere with itself to control where it lands on the screen. As if is something that people might object to. So the statement is that the electron explores both routes at the same time, at once, let's say, on its route from the electron gun through the slits to the screen. So that's a very strange picture of reality. But that experiment, which I emphasize has been done now many times, tells us that nature is not like that. It tells us that the electron must, in some sense, explore all routes on the way from the gun to the screen. And I think many physicists now would say that that is a correct description of reality. The problem with quantum mechanics, I suppose, is when you try to interpret what the calculation means for the nature of reality.